So we will start until the rest join us. Ahmed Al-Mullah. Start with the first question, Ahmed. Start with the reading the first one. Ahmed, do you have mic? Ahmed? Don't have a mic. طيب. Muhannad. Faisal comes the last one. Muhannad.
Yes, sir.
Read this question. Question 1.
Substance A has a density of 3 grams per cubic centimeter, and substance B has a density of 4 grams per cubic centimeter. In order to obtain equal masses of these two substances, what must be the ratio of the volume of A to the volume of B?
So he's asking about you have two substances with two different densities. In order to obtain equal masses of these two substances, what must be the ratio of the volume of A and the volume B? You have to do it with equation. Let me start. If you can do it with the equation, do it. I'll show you how to do it first. We have two equal masses, MA equal to MB. Okay. And what is the relation between mass and density, Mohammed?
Mass equal density times volume.
Bravo. So mass equal density, so it will be dA multiplied by volume VA equal to, we use the hint that they have equal masses. This is the hint that you will start with it. And here we have D density of B multiplied by volume of B. So go back to the question, what exactly does he need? The ratio of volume A, he wants volume A to volume B. So come back here, I want volume A to volume B, so I will move B to the other side, here, and density A will be to the other side. Density of A will move to the other side here. So what we get in the end that volume A over volume B equal D density of B divided by density of A. Let's go back. What is density of B and density of A? Density of A is 3 and density of B is 4. So it's 4 over 3. So it's 4 over what? Over 3. So let's go back and see the answers. What would be the right answer, Mohammed?
B.
Yes, the answer would be B. The answer is what? Is B. So if we come here, we won't do this all the time. Here from this, if you have equal masses, we can make a statement or deduce a relationship. If you have equal masses, what is the relation between density and the volume? Inversely proportional or directly proportional, Mohammed? Volume and density are inversely proportional when you have mass, when mass is what? Is constant. When you have a constant mass equal constant, then you can say what? If you have this condition, that you have equal masses, so the volume and density, they are inversely proportional. So I can say like that. V1 over V2, volume 1 over V2 equal density 2 divided by density 1. So you can do that directly. If you have equal masses, you can reach to this relationship directly if you have constant mass. The relation between, or the ratio between two volumes equal to the opposite ratio between the densities, opposite ratio. So V1 over V2 equal D2 over D1, density 2 over D1. That's because of what? That's because they are in multiplied here. In the equation, density, mass equal density multiplied by volume. Okay, guys? So let's go back and read the second question. So we have some students here. So let's go back and participate with us. Ahmed Anwar, you don't have a mic. طيب أحمد توفيق المشعل. أحمد توفيق. Ahmed. Also don't have a mic. How would you participate, guys, without a mic? Faisal? Faisal.
Yes.
Faisal, read question 2.
Number 2, a hollow sphere of negligible mass and radius r is completely filled with a liquid, so that its density is rho. When you enlarge the sphere so its radius is 2r and completely fill it with the same liquid, what is the density of the enlarged sphere?
What is the density of enlarged sphere? So he's talking about density again, a hollow sphere of negligible mass. The sphere has no mass, okay? And radius r is completely filled with liquid so that its density is rho. The density is what? Is rho. You now enlarge the sphere. Remember, the sphere here is negligible mass. We don't mention it. You mean that you changed the volume of the liquid, only the volume of the liquid. Enlarge the sphere so its radius became 2r and completely filled it with the same liquid. What is the density of the enlarged sphere? Do you know the answer, Faisal, to this question?
I do process of elimination. It's not C or E, and it's not D because we enlarged it. I think it's B.
So, do you know the density is constant for the same type, regardless of the mass, regardless of the volume, for the same substance? For example, if I said the density of water is 1000 for 1 cubic meter of water, if I make it 4 cubic of water, increase the volume, I would have the same density. Thank you. So the density does not depend on the mass or the volume of the sample that you have it. It depends on the type of the material. Here, did we change the type of the material?
No.
Okay. Did we change because if you have different, for example, if you have a steel, pure steel, a block of steel, you will have a density of the steel. If you make it a hollow, like a shape, you make a shape of this, so it will have a different density. This is called the density of objects. So here he's talking about an object, the density of a sphere of completely a liquid. And we enlarge the sphere. What do you think would happen? Did we change the liquid shape so we would have another density for the object, or we will have the same density?
The same density. The
same density, because we have the sphere of water, we make it the same sphere completely filled with water, and we double it. If you triple it, you still have the same what? The same density. And that's because, let me add another slide here, and that's because density equal mass over volume. Let's say M1 over V1. If you increase the volume, you will have V2 and M2, and the ratio will still be the what? Will be the same density, unless you are calculating. This is the density for block object. That is there is no spaces, or there is no other materials involved in it. You have a pure liquid with volume V1 and M1, or pure sphere of a liquid V1 and M1. You increase the volume with the same liquid, and there is no spaces, there is no other liquid added. So we have V2, we must have M2, and the ratio between them will give you the same density. Okay, Faisal? Because we didn't what? We didn't add a space to the new volume. We didn't add another liquid or another substance. So we'd have the same liquid. We only increased the sample, volume of the sample. So the mass of the sample will increase by the same ratio to give you the same density. So density does not depend on the sample for a substance, on the sample volume or mass, because you didn't add any impurities to the sample. You didn't add other liquids or other solids to the sample, so you will have the same density. So the answer is D, rho. So what is it? What is the question? Oh, I went on this one. Hassan? Hassan? Okay, Hassan. Question 3.
Styrofoam sphere of radius r has density d. You now carefully compress the sphere so its radius is r/2. What is the density of the compressed sphere?
How did you calculate it, A?
So basically, the sphere stays with the same mass, but the volume decreases. And as you said, the density and the volume are inversely proportional. So when the volume decreases by half, the density will divide by.
But he didn't say volume, he said radius, not the volume. He decreased the radius, not the volume.
It's the same thing, Mr. The sphere, the radius will decrease the volume.
What is the equation to calculate the volume of a sphere?
4/3 pi r/3, I guess.
So let's type it here for you. So volume of a sphere equal 4/3 by r cubic, صح؟ مظبوط كده؟ Okay. So we want to calculate the density, and we changed the density. So the new density d1 over d2, and they have inversely proportional with the volume, equal v2 over v1. But here the volume, the relation between volume, you can cancel this. So I can type this. It will be 4/3 by r2 cubic divided by 4/3 by r1 cubic. And what should we do? We will cancel this one with this one. So if you want to replace another relation using the radius, Hassan, with volume, you will use what? You will use r cubic, not r only. So the equation will be like this. The d1 over d2 equal r2, but cubic, Hassan, divided by r1 over 3, or bar 3. So let's go back and see what happened to the radius. A styrofoam sphere of radius r and the density rho. Okay, this is the first situation, or the first condition. You now carefully compress the sphere so its radius is r/2. The radius is decreased to r/2. So the new radius is half the radius of R1. So we can type it like this here. The new radius R2 equal R1 over 2. I can use this equation here and replace R2 with R1 over 2. So D1 divided by D2 would equal to R2 R1 over 2. يبقى R1 over 2 all cubic divided by R1 cubic will equal to R1 cubic divided by 2 to the power 3 divided by R1 cubic. So what would we have? We'll cancel R1 with R1 and 2 over 3. So we'll have that D1 density 1 to density 2 equal what? 1 over 2 to the power 3 equal 8. 1 over 8. So if you have D1 equal rho over D2 density 2 equal 1 over 8. So D2 would equal 8 multiplied by rho. That's how to calculate it, Hassan. Okay. So
Okay.
let's go back. So let's go back here. So the answer would be what?
E.
Yes, the answer would be E. That's it. Okay. So we started with the concept that the relation between this concept that I explained it before, the relation between volume and density are inversely proportional. That's it. Because we have the same mass. So next question. Let's see what's the next one. Karim.
Yeah.
Okay, Karim. Can you read this question?
When a box rests on a round sheet of wood on the ground, it exerts an average pressure P on the wood. If the wood is replaced by a sheet that has half the diameter of the original piece, what is the new average pressure?
This is a new thing. This is, the chapter 12, you can call it a crash course about gases, liquids, and solids. We talked about densities, about pressure. So Karim, what is the formula that you use it to calculate pressure? Pressure equal what?
You just cut off. What did he say?
Pressure equal what? What is the formula that we use it to calculate pressure?
Hold on. Is it P
Equal force divided by what?
I don't remember. I'm sleepy, so I can't remember anything.
Over area. Pressure equal force divided by area. So if you have the same force, if you have force is constant, similar to the density one, if the force equal constant, so we'll have what? So you can retype it like this. Force equal pressure. Sorry. Force equal pressure multiplied by area. So if we have force is constant, then we would have that pressure is inversely proportional to the area. Pressure is inversely, because they are multiplied here and equal constant, multiply inversely proportional with area. From that I could say, this is very important relationship. From here we could say that B1, because they are inversely proportional, over B2 equal A2. This is the meaning of, or how to deal with inversely proportional situations. Equal A2 divided by A1. So that relationship, you can directly use it if you have the same force. Let's go back to the question. Do we have here the same force, Karim?
What?
Yes. When a box rests on a round sheet, we didn't change the box. The weight of the box, we didn't change it.
No.
Okay. On the wood. If the wood is replaced by a sheet that has half the diameter, we decrease the diameter. In the same equation here, what is the, how to calculate area? Area equal what? How to calculate area of a round sheet, a round thing, round sphere, round sheet, or a circle, round sheet. That's it. How to calculate it? Area equal what? By
R
squared.
What was it? Q squared, yeah.
Squared by R squared, by R squared. Okay, so we can replace A2 here with this. By R, this is will be A2, so this is by R2 squared, R2 squared, divided by R1 squared. This one come from here, and this one come from here. Okay, so we cancel what? We cancel by with by, and what is left? That B1 over B2, the relation between pressure, equal A2 over A1. As we said, they are inversely proportional. A2 over A1. If you use the radius, it will be R2 squared. Don't forget that. It will be R2 squared divided by R1 squared. We just extended to include what? To include the radius. That's it. And this is the radius for what? For something round. So here we is talking about, let's go back to the problem. He what to the sheet? Replaced by a sheet that have the diameter. So the new one is half the first one. The new one equal half of the first one. So we can type here that the new one is half. The new one, which is R2, the new diameter, equal half of the first one. That's how to translate the problem. The new one, which is R2, the new radius, is half of the first one. That's it. So let's come back here and type it here. So B1 divided by B2 equal R2, I will put it as it is, R2 squared. So R from here, from equation, R2 squared. R2 squared. Divided by, instead of, sorry, I will put R2 with half R1 squared. R2, this one, I will replace it with R1 squared. Let me just correct it. Because I'll use the equation. I will not use R2. I will use this equation. What equals R2 here is half R1. So I'm going to put here half R1. This is what, this is R2 from the equation. R2 equal half R1. And then I'll put the square over all of that. Okay. Divided by R1 squared. And that would equal to 1 over 2 squared multiplied by r squared, r1 squared. Okay, all of this divided by r1 squared. So we cancel this one out with this one. So equal, what's left here? 1 over 4 from this equation. 4. So P1 would equal B2, or B2 will equal 4B1. Let's type it as the equation is asking about. B2 multiplied by 1, which is B2, would equal 4B1. So the numerator pressure will be 4 times as the pressure 1. Okay. So let's go back to the question, Karim, and the answer will be what? What is the answer?
A.
A, yes. What's the new average, the new pressure, which means the new pressure, which is B2, will be 4B. It increased. The answer is A. Okay. Let's see someone else. Next one, Khalid, you have a mic? Khalid. Okay, Khalid, you don't have a mic, so I'll pick the next one. Kumail. Kumail. Kumail is here?
Yes, hello, Mr.
Okay, Kumail. Can you read the next question, please? Question 5.
Okay. When a heavy metal block is supported by a cylindrical vertical post of radius r, it exerts a force F on the post. If the diameter of the post is increased to r, what force does the block now exert on the post?
So when a heavy metal block is supported by a cylindrical vertical post of radius r, so you have a post with a radius r. It exerts a force F on the post. If the diameter of the post is increased to 2r, you increase the diameter. No, the radius, the diameter is increased to 2r. What force does the block now exerts on the post? Do you know the answer for that one, Kumail? Anyone can solve it,
Mister,
guys?
how does this make sense, mister? If it has radius r.
When a heavy, read it from the first. When a heavy metal block is supported by a cylindrical vertical post, so you have a cylindrical post or something cylindrical that is supported, or you put a metal block over it, and it has a cylindrical shape
Yes,
of radius
mister.
r.
If it has radius r, if the diameter of the post is increased to 2r, it's not increased, mister. The diameter is 2r anyway. How does this make sense?
So this is maybe the radius. This is maybe a mistake with it, but let's solve it with this sense. When the heavy block is passed by cylindrical vertical of radius, so this is radius. So this is a mistake.
So if they increase the radius times 2?
Radius, yes, times 2, because he types here increase to 2r, and he typed here r, so he means that this is what? This is the double of the first one. So radius increased to 2r, okay? If the diameter, so not the diameter, radius of the post is increased to 2r, what force does the block now exert on the post? Remember, he's not asking about the pressure, he's asking about the force. And this is the big difference between force and pressure.
The force will be the same, right, mister?
Yes, it will be the same. So, oh, sorry. It was question 5. Because force comes from not the cylindrical post, it comes from the block. Come from the block itself. So the answer would be the same force. D, the same force. So here, this question only to distinguish between force and the pressure. If you're asking about pressure, it will be different. But force does not depend on the area at all. Force depends on the weight of the block, which is above the post. So it didn't change, so we have the same force because the same weight. So let's read this question and pick someone from here. مشعل. مشعل. مشعل عتيبي. محمد بودي. محمد بودي. مهند answer before. عمر. يحيى. طيب احنا دلوقتي في حصه مراجعه ولازم المايك يكون شغال. كيف هنشتغل وعندك خالد ما جابش وعمر ما جابش واحمد الملا معهوش مايك؟ كيف هنشتغل؟ يحيى زير. يحيى. طيب نعيد من الاول تاني. عبد الله الملحم زير. عبد الله الملحم. عبد الله الملحم is not here, absent. Let's start from the beginning. طيب I will show those who don't have a mic to the problem, Ahmed al-Mullah, and you will solve it and send the answer on the chat area. I will read it and you will solve that and send the answer. As shown in the figure, fluid fills a container having several sections. At which of the indicated points is the pressure greatest? You have point A, you have point B, and C, and D. And he's asking about this point here in this one, and point B here in this one, and C and D. And he's asking at which point you have the greatest pressure. And you have answers here, Ahmed, A, B, C, D, and the pressure in the is the same at each of the labeled points. So choose one answer here, Ahmed, from A to E, and type it in the chat area. E, bravo عليك Ahmed. Because here they have the same height above them of water. We don't depend on the inclined one or the slanted one. We depend on the vertical height. All of them, A, B, C, D, all of them have the same vertical height. From the top, the surface, to the end, they have the same height. It doesn't depend on the cross section of the tube. It doesn't depend if it is vertical or slanted. It doesn't depend if it's curved or straight. It doesn't depend on anything. It depends only on the height from the surface to the point. So all of them have the same height, the same H. So all of them have the same pressure. Thank you, Ahmed. Question 7. Ahmed al-Mish'al, you read it and I will read it for you and you will solve it. Consider a brick that is totally immersed in water with the long edge of the brick vertical. The pressure on the brick is the same in all surfaces of the brick, greatest on the surface with the largest area, greatest on the top of the brick, greatest on the sides of the brick, greatest on the bottom of the brick. Again, you have to imagine that, or try to figure it with your mind first. Imagine it with your mind, your imagination. Consider a brick that is totally a brick, totally pressed and compressed, immersed in water. Let me draw it for you here. So can you imagine it? You have a basin of water like this, and you have a brick. That's the brick. You know, the brick is totally. This is the side view for the brick, totally immersed in water, as you see right now, and that is water level here above the brick. All this is water, and now he is asking about the pressure. The pressure immersed in the water with the long edge of the brick vertical. Long edge is vertical, so let's come here and adjust it. Something like this. Okay, this is a brick, sorry, on this one. Okay, it's vertical like this. The pressure on the brick is the same on all surfaces of the brick. You have different surfaces, as you see. You have this surface here, and you have another surface here, and surface here, and surface here. Let me count them for you. 1, 2, 3, 4. You have this counting for them, so you can answer them. The pressure on the brick is the same on all surfaces of the brick. The greatest on the face with largest area, greatest on the top of the brick, greatest on the sides of the brick, greatest on the bottom of the brick. What do you think? What is the right answer? Type the answer on the chat area. This is the last question. 1 minute and we will end the session. أحمد وأحمد معانا ولا غايب يا شباب؟ أحمد المشعل. Yes. طيب فيصل, can you answer it? Faisal? We have different sizes here. Do you remember that we take this exact same figure in the PowerPoint? We studied it before. I said in the horizontal sides here, on 1 and 2, we have the same pressure. They have equal pressures. They cancel out each other, because at each point you have another point that is opposite it and cancel it out. But here in the vertical ones, you have what?
It's not equal, Mr.
Yes, in the vertical they're not equal. So which one has greatest? Number 3 or number 4? Which face has greater pressure on it? 3 or 4?
I think it's 3.
No, because you go down, you increase the pressure. So once the bottom of the brick is
But then
far
you have
away.
small left here. Smaller space, Mr.
No, the same area here. You see the same area, but the pressure here depends only on the height. You have only this height here for 3, but for 4, for the bottom of the brick, you have much larger heights. This is height for number 4. Okay, for the point number 4, but for 3 you only have this height, and that's what makes it the buoyance force. Okay, guys.
So Mr. In number 4, we don't calculate from the object to the bottom.
We calculate the pressure depending on the height. So the height here, the height here is much greater than the height here. So number 3 has only a pressure according to this height, but 4 has a pressure according to all of this height.
Because I calculate from the bottom line all the way to the floor.
Yes, to the not the floor, not from this line here till the surface of the water. This is the water surface.
Okay.
Okay. So the answer would be what? E, greatest on the bottom of the brick. Okay, guys, thank you for listening and see you in the next session tomorrow, inshallah. Have a nice day.